So you have a lot of tests in front of you. Could you maybe explain some of them?
Absolutely. So there's a few different classes of tests that I just have here, and there's more tests. There's many more different tests out in the world too. These are one class of test. These are rapid antigen tests that are just the most bare bones paper strip tests. These uh, are this is the type that I want to see produced in the tens of millions every day.
Mhm.
It's so simple. You don't even need the plastic cartridge. You can just make the paper strip, and you could have a little tube like this that you just dunk the paper strip into. You don't actually need the plastic, which I'd actually prefer, because if we start making tens of millions of these, this becomes a lot of waste.
Mhm.
So I'd rather not see this kind of waste be out there. And there's a few companies. Quidel is making a test called the Quick View, which is just this. It's they've gotten rid of all the plastic.
And for people who are just listening to this, we're looking at some very small tests that fit in the palm of your hand, and they're basically paper strips fit into different containers. And that's hence the comment about the plastic containers.
These are just injection molded, I think, and
Got it.
they're they can build them at high numbers, but then they have to like place them in there appropriately and all this stuff. So it is a bottleneck, or somewhat of a bottleneck in manufacturing. The actual bottleneck, which the government I think should use the Defense Productions Act to build up, is there's a nitrocellulose membrane, a laminated membrane on this that allows the material, the buffer and with the swab mixture to flow across it. So the way these work, they're called lateral flow tests. And you take a swab, you swab the front of your nose, you dunk that swab into some buffer, and then you put a couple drops of that buffer onto the lateral flow. And just like paper, if you dip a piece of paper into a cup of water, the paper will pull the water up through capillary action. This actually works very similarly. It flows through somewhat of capillary action through this nitrocellulose membrane. And there's little antibodies on there, these little proteins that are very specific, in this case for antigens, or proteins of the virus. So these are antibodies similar to the antibodies that our body makes from our immune system, but they're just printed on these lateral flow tests, and they're printed just like a line. So then you slice these all up into individual ones. And if there's any virus on that buffer as it flows across, the antibodies grab that virus, and it creates a little reaction with some colloids in here that cause it to turn dark, just like a pregnancy test. One line means negative, it means the control strip worked, and two lines mean positive. It means, but if you get two lines, it just means you have virus there. You're very, very likely to have virus there. And so they're super simple. It is the exact same technology as pregnancy tests. It's the technology, this particular one from Abbott. This has been used for other infectious diseases like malaria, and actually a number of these companies have made malaria tests that do the exact same thing. So they just co-opted the same form factor and just changed the antibody so it picks up SARS-CoV-2 instead of other infections.
Is it also the Abbott one? Is it also a strip?
Yep. Yeah. This Abbott one here is in this case, instead of being put in a plastic sheath, it's just put in a cardboard thing and literally glued on. I mean, it looks like nothing, it's just, it looks like it's just the simplest thing you could imagine.
The exterior packaging looks very Apple-like. That's nice.
It does. Yeah. 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 So it's nice.
all
And it
about the
comes
branding.
in, this is how they're packaged, so and they don't have to, these are coming in individual packages again, because they're really considered individual medical devices, but you could package them in, bigger packets and stuff. You want to be careful with humidity. So they all have a little, one of those humidity removing things and oxygen removing things. So this is one class, these antigen tests.
If we could just pause for a second, if it's okay, and could you just briefly say what is an antigen test and what other tests there are out there, like categories of tests?
Sure.
Just really quick.
So the testing landscape is a little bit complicated, but I'll break it down. There's really just three major classes of tests. We'll start with the first two. The first two tests are just looking for the virus or looking for antibodies against the virus. So we've heard about serology tests, or maybe some people have heard about it. those are a different kind of test. They're looking to see, has somebody in the past, does somebody have an immune response against the virus, which would indicate that they were infected or exposed to it. So we're not talking about the antibody tests. I'll just leave it at that. Those, they actually can look very similar to this, or they can be done in a laboratory. Those are usually done from blood, and they're looking for an immune response to the virus. So that's one. Everything I'm talking about here is looking for the virus itself, not the immune response to the virus. And so there's two ways to look for the virus. You can either look for the genetic code of the virus, like the RNA, just like the DNA of somebody's human cells, or you can look for the proteins themselves, the antigens of the virus. So I like to differentiate them. If you were a PCR test that looks for RNA in, let's say if we made it against humans, it would be looking for the DNA inside of our cells. That would be actually looking for our genetic code. The equivalent to an antigen test is sort of a test that like actually is looking for our eyes or our nose or physical features of our body that would delineate, okay, this is Michael, for example. And so you're either looking for a sequence or you're looking for a structure. The PCR tests that a lot of people have gotten now, and they're done in labs usually, are looking for the sequence of the virus, which is RNA. This test here, by a company called Detect, this is one of Jonathan Rothberg's companies. He's the guy who helped create modern-day sequencing and all kinds of other things. So this Detect device, that's just the name of the company. This is actually a rapid RNA detection device. So it's almost, it's like a PCR-like test, and we could even do it here. It's a beautiful test, in my opinion. It works exceedingly well. It's going to be a little bit more expensive, so I think it could be used as a confirmatory test for these.
Is there a greater accuracy to it?
Yes, I would say that there is a greater accuracy. There's also a downfall, though, of PCR and tests that look for RNA. They can sometimes detect somebody who is no longer infectious. So you have the RNA test, and then you have these antigen tests. Yes. The antigen tests look for structures, but they're generally only going to turn positive if people have actively replicating virus in them. And so what happens after an infection dissipates, you've just gone from having sort of a spike. So if you get infected, maybe 3 days later, the virus gets into exponential growth, and it can replicate to trillions of viruses inside the body. Your immune system then kind of tackles it and beats it down to nothing. But what ends up in the wake of that, you just had a battle. You had this massive battle that just took place inside your upper respiratory tract. And because of that, you've had trillions and trillions of viruses go to zero, essentially. But the RNA is still there. It's these remnants. In the same way that if you go to a crime scene and blood was sort of spread all over the crime scene, you're going to find a lot of DNA. There's tons of DNA. There's no people anymore, but there's a lot of DNA there. Same thing happens here. And so what's happening with PCR testing is when people go and use these exceedingly high sensitivity PCR tests, people will stay positive for weeks or months after their infection has subsided, which has caused a lot of problems, in my opinion. It's problems that the CDC and the FDA and doctors don't want to deal with. But I've tried to publish on it. I've tried to, suggest that this is an issue, both to New York Times and others. And now it's unfortunately kind of taken on a life of its own of conspiracy theorists thinking that they call it a case-demic. They say, PCR it's detecting people who are false positive. They're not false positives. They're late positives, no longer transmissible.
I think the way you, like what I saw on rapidtest.org, I really like the distinction between diagnostic sensitivity and contagiousness sensitivity. It's so, that website is so obvious that it's painful, because it's like, yeah, that's what we should be talking about, is how accurately is a test able to detect your contagiousness. And you have different plots that show that actually there's, that antigen tests, the tests we're looking at today, like rapid tests, are actually really good at detecting contagiousness.
Absolutely.